All right, so working on the Beetle again, and today we're trying to get our pistons and cylinders and the cylinder heads all put on. But before we do that, we've been trying to find out what our compression ratio is, and the reason why that's important is because your compression ratio directly impacts the kind of fuel that you can use. And so if you have a higher compression ratio, that gives you more performance, but it means that you'll have to take a higher octane fuel. So instead of being able to use 87 at the pump, like most people do, you'll have to end up, taking 89, 92, and so on. Which, if it's not a daily driver, then maybe that won't be, too important to you. But if you start driving it more, then, your pocketbook may not really like that. So the key to being able to get the 87 at the pump is to lower your compression ratio. On average, 1600 VW engine had around about a 7.5 to 1 compression ratio, and from what we've read, they said anywhere between 7 and 8 is acceptable. The reason for that is that the higher your compression ratio, the hotter the engine will run, which is why you have to take the higher octane fuel to keep those temperatures down. In order to find your compression ratio, you have to do a couple of things. You have to know first your deck height, and your deck height is going to be the distance from here. You can see I've got a cylinder and a piston. The piston's down in there. This is the top of the cylinder right here. Your deck height is going to be the distance from the top of the piston down there to the top of your cylinder when this is at top dead center, meaning that piston is going to be pushed all the way up. So the space between the top of the piston and the top of this cylinder, which is going to be real small and marginal. And the way that you figure that out is you bring it to top dead center. The way that you do that is with this on your connecting rod right here. This is cylinder number 1. You're going to take your crank and you're going to turn it all the way around until this guy is all the way up. Your piston's going to be all the way up. And then as you pull it, you'll notice that that piston starts to go back down just a little bit. You want to stop and rock it back counterclockwise to bring it back up, and then you'll see it kind of go down and then up and down as you go back and forth until you find the spot where you can rock the pulley just slightly and the piston doesn't move. That's going to be top dead center for number 1. Once you've got that, there are a couple of ways of checking all of this. And there's some more, definitely some more accurate ways of doing it. We kind of did a combination of a few things. The first thing that you can do is you can take a hard straight edge like this guy here, and you can set it across the top, and you want to do it in the direction of your wrist pin because your piston can rock a little bit. So you want it to be in the direction of the wrist pin, parallel to it. And then you can take your feeler gauges and stick it up underneath this straight edge, between the straight edge and the top of the piston, to find out what that distance is. Your feeler gauges, and I had some around here somewhere. Guess I ended up putting them away. Sorry, I wanted to show that to you. They have disappeared. Anyways, your feeler gauges are going to be in some people do with millimeters. Ours were in inches, so it'd be thousandths of inches. So you can have on those you'll have a 1, a 2, a 3, a 4, all the way up to a 25, I think, on ours. So that would have been a 25 would have been a 25 thousandths of an inch. So you take those and you kind of have to combine several of them to find out what your deck height is going to be. And as we did it, we found that ours was at 57 thousandths of an inch. Another way to check it is to there is another method where you take basically a straight edge like this with a bolt, and you take it and you sit it down on top like this. You turn this bolt down until it touches the top of the piston. And that will end up giving you, a fairly accurate reading. Sorry, I need to lay this down so it doesn't fall. And then, as you can see here, that bolt is sticking out just a little bit. Then you can check that distance using a caliper. So we did it several ways just to try to find, double check ourselves with it, and we ended up finding out that it was 57 thousandths of an inch. That's our deck height. Now, in order to move on over to the compression, you have to find out, convert your deck height to deck volume. So you've got the height from the piston to the top of the cylinder, but you need to find the volume of that entire space. And, sorry, he's blowing that out. So to find out the deck height, you have to take your bore size and multiply it by itself. So our bore size is 88. Sorry. Our bore size is 88, and then you multiply that times your deck height, which was 0.057, and then multiply that times 0.01996. So again, it's your bore size times itself, then multiply that times your deck height, and then multiply that times 0.01996, and that's going to give you your deck volume. So ours came out to be around like 8.2 or 8.4, somewhere around there for our deck volume. Now you can move over towards your compression, and the site that really helped us, there's a site called Zoom Aviation, ZOOM aviation.com. And they had a whole thing on there about VW engines with all of these different formulas. So you can go check that out there. And so to figure out the compression ratio, you have to plug in a couple of numbers and find out a couple other things. One, you have to know your head volume. So here on your, this is your cylinder head, as you can see here. You have to find out the volume of this area right here. So the way that you do that is you end up taking this and leveling it off. And then if you can go buy a kit with a piece of plexiglass that can sit down. It's round and will sit down into this. Another way to do it, we didn't do it with the plexiglass, but you just take a syringe here. Just so you know, milliliters and cc's are the same. It's the same definition for volume in metric. So we took a 60 milliliter syringe here, filled it up with water, and then you begin to squirt it down here. And what you want to do is you want it to fill up to that point right there, and then you have to fill a little bit more. You see this little edge that comes around on the inside right there? This kind of deck right there and that deck right there. You want the water to spill over to that. On average, on a 1600, they said it's anywhere between 51 and 54 milliliters. Ours ended up being right at 54 milliliters, or 54 cc's. Again, those terms are interchangeable. So in order to do that, you have to put your valves in, as well as your spark plug. Before you do that, you have to seat or lap your valves, which I've talked about in another video, where you take your valves, you put some grinding compound like that stuff and on it, and then you spin it inside. As you can see the real shiny metal there on the inside. So you're giving it a new seat, so it's good and tight. So you put your valves in, you spark plug in, and then you check for your head volume, which you can just use water. 60 milliliter syringe here, pour it in the top, let it spill over onto that area right there. If you have the plexiglass that you can sit down in there, that'll help even more, but you can kind of get a good in the ballpark of it. So ours was 54 cc's. So now that we have the head volume, there's a formula on Zoom Aviation's website that you can plug in. It's actually a calculator. You can plug in the numbers. You take your head volume and you add it to your deck volume, and you add it to, you take the displacement of one cylinder. With our bore and our stroke, that gives us a displacement of 1680 cc's. Divide that by four cylinders, and it gives you 420. So you add the deck volume plus the head volume plus 420, and divide that by the deck and head volume, I believe. It's on the site there, and that will give you your compression ratio. Right now, our compression ratio is about 7.9, somewhere in there, which is acceptable. It's, below 8. We'll still have performance, but it'll be able to take 87 octane. So now that we know all that, we can begin to put all this back together. If your compression ratio was too high, what you would have to do is use some shims that would end up sitting right here in order to raise the cylinder up. By raising the cylinder, that's going to lower the piston head from the top of the cylinder, which will lower your compression ratio. There's a couple of ways of doing that. You can get metal steel shims to do that, and usually those steel shims come in 10,000ths of an inch. You can also, we've heard that you can use paper gaskets. One of our local guys talks about cutting out his own paper gaskets. You can do it out of regular paper. A sheet of 20-pound paper that you use like in your printer at home is about 3 or 4 thousandths of an inch. So you can do regular gasket material if you want to. So, but ours, because ours is right there where we need it, we don't have to use a gasket. We're just going to use some sealant, like some Permatex on there, put it in, and call it a day. So that's about what we're about to do now. We're going to take those cylinders, going to put them back in on here with the pistons, put some Permatex on it, get the head on, and that'll be done on this this right side of the case, and then we can go to the left side and do the same thing. So I hope that helps you guys. If you got any questions, just post it down there beneath the video.